Next is block and tackle pulley system, which is containing 5 pulleys. Before we start with block and tackle pulley system, you should know what is this block. You should know what is this block and what is tackle. Now, block is nothing but the set of pulleys which are fixed. There are set of pulleys which are fixed. You can see in this diagram. These are the set of pulleys which are fixed here for the rigid support. These are fixed here for the rigid support. Then the tackle is the set of pulleys which are movable. You can see here, these are the 2 pulleys or set of pulleys which are movable, which can move in upward direction also as well as in downward direction. Okay, so this is called as block. The set of pulleys which are fixed and the set of pulleys which are movable is called tackle. Now we are discussing the block and tackle pulley system containing 5 pulleys. You can see in this diagram here, there are 5 pulleys, 3 plus 2, 5 pulleys in this block and tackle. Total is 5 pulleys. A very important note that you have to remember in this block and tackle pulley system, that is number of pulleys in block. Number of pulleys in block should be 1 more than number of pulleys in tackle. Always remember this. Number of pulleys in this block should be 1 more than number of pulleys in this tackle. Suppose there are 5 pulleys in this example only. It should be 3 in block and 2 in tackle. Suppose there are 3 pulleys, then it should be 2 in block and 1 in tackle. 2 should be fixed and 1 should be movable. Suppose there are 7 pulleys, then 4 in the block and 3 in the tackle. Okay, 1 more. Always block should be, these all are block number of pulleys. Number of pulleys here are 1 more. 3 plus 1 2, 2 plus 1 2 plus 1 3, 4 plus 1 3, so it is total 7. Yes or no? Now let us discuss this pulley system containing 5 pulleys. You can see in this diagram, this is the load which is supported by 5 strings. 1, this is 1, 2, 1, this is 1 T here, 2T, 3T, 4T and 5T. So there are 5 strings which are supporting here. You can see these are the 5 strings which are supporting the load, and effort is acting in downward direction here. You can see this effort is applied only on 1 string. You can see this string, only 1 string. Okay. So therefore effort in this pulley system is equal to T and load will be equal to 5T. You can see I have counted here. Load will be equal to 5T. So this is T, 1, 2, 2, 3, 4 and this is 1/5 one. So there are 5 T's here. So mechanical advantage is given by load upon effort. Load is 5T and effort is T. So T will cancel. You will get mechanical advantage as 5. The next one is velocity ratio. Velocity ratio is given by distance traveled by effort to distance traveled by load, as we know the formula. Velocity ratio is equal to phi x upon x. Now what is this phi x and x? Distance traveled by effort will be phi x and distance traveled by load will be x. As like a single movable pulley, you have seen that if the effort is moving in downward direction and if it travels a distance d, load will travel half of that. But here there are total 5 pulleys. Total 5 pulleys are there. So distance traveled by effort will be 5 times the distance traveled by load, or distance traveled by load is 1/5 the distance traveled by effort. So velocity ratio is given by phi x upon x. Therefore if x cancels, velocity ratio will be equal to phi. Okay.